Tag, Freundin von Unperfekthaus. This is Thomas Culhane, or T.H. Culhane from Solar Cities. We're in the Schaltwerk part of Unperfekthaus with Dominic Jais, if I pronounce your name right. And we're looking today at the incredible Joule Thief circuit that was discovered, I think, somewhere around the turn of the last century, 1999 or so. And it has enormous potential for third world development applications and for disaster preparedness here in Germany and around the world, because it enables us to, as you can see, light super bright LEDs like this one here using nothing more than the tab of an aluminum can, a tissue paper soaked in some drain cleaner, Rohrreiniger, and any source of stainless steel as the other electrode. And once I touch it, as you can see, the light goes on. And this little tab, and I have many of them, each tab can last about 2 nights. And that can power not just one LED, but I've powered in Nepal up to 5 LEDs and read books in my tent up in the Himalayas in villages with no electricity using these tabs. I carry them in my pocket, and you find them on the trail all the way to Mount Everest. So it's not like they're hard. You don't have to bring any with you, because people are constantly throwing beer cans and soda cans away. On airplanes, the stewardesses now, when they get to know me, they will collect the tabs from the people on the airplane and give me handfuls of them. So that's a really useful thing, and we'll show that you can not only use the aluminum tab, but you can also use zinc. So zinc nails or screws like this one will also make the light go on. We might need just a little bit more of the sodium hydroxide just to get the oxygen off, and we'll give it a few seconds, but it will light. Hold on. This one does take a little bit longer, just as I said, because the there it goes. So it might be that we have a short circuit because this is an old piece of tissue paper. The tissue paper you can replace with a sponge, and then of course it doesn't deteriorate. So tissue paper I'm just using now for convenience. And there it goes. Okay, so now it's on and it's super bright, as you can see. And that's just, as I said, with zinc nails. And that means in a third world country, everybody has zinc roofs, so you can just shave a little bit of your zinc roof off, or the extra tailings after people have cut the zinc roof. There's a lot of waste zinc. You can also use, by the way, I don't know if I have it to show, but you can use plumbing pipes like this, and they'll last almost forever. So I'll take out the zinc and take the piece of plumbing pipe and just take my paper towel that's a bit wetted with the sodium hydroxide and put that down and give it a few seconds to eat away at the coating, and we should start to, there it goes, and it lights. And that really works. You don't need Rohrreiniger, you don't need sodium hydroxide. You can use potassium hydroxide, KOH, which you can get from wood ashes. So along the Sherpa Trail in Nepal, everybody is burning rhododendron wood for their fires, their campfires. You just gather the ashes and put it in water, and you've got this solution. So no matter where you go in the world, as long as you have a source of wood ash, it can be fruit wood trimming, so you don't have to chop any trees down. All of the apple trees and pear trees and cherry trees always need to be pruned. You can use that wood, it's rich in potassium. You can use palm fronds, which are always coming off of palm trees. Burn it, get the heat and the light and the warmth from that, and then take the ash and make your solution, and then use any bit of zinc or aluminum cans, or even you'll find a lot of dinner plate aluminum foil just thrown away, which is cruddy and gucked up with all sorts of food. Nobody's going to recycle it. So you can just gather that and use that as your source of electricity as well. So there's really an enormous range of materials that you can use to create bright light for electricity. But it's all thanks to the Joule Thief. And so let's take a look at the Joule Thief. Before we do, though, one other thing I should mention is that if you don't have garbage to use, you can use batteries. And here's the amazing thing. This is a 3-volt LED. So you'd think you need a 3-volt battery to light it. Normally you do. If you're going to take an LED, and I think I've got an extra one around here. There it is. If you're going to take an LED and you have a single battery, you will note that even though the battery is good, it will not light. Okay, so now if I hook two batteries together, then the LED, as you can see, lights up. Can you see that? Okay. Yes. So an LED that's 3 volts obviously needs 3 volts. But here's the incredible thing. With a Joule Thief circuit, you can use a 1.5 volt battery with a 3 volt LED, and you can get the same, or even more, is if I can hook it up right. Take that magnet off. Oh, I'm not using the Joule Thief. Of course, I'd have to use the Joule Thief. So, what was I thinking? So the Joule Thief circuit is going to go in between these neodymium magnets. They're just to hold the electrodes on, and boom. Now you're lighting a super, super bright LED off of a 1.5 volt battery. And here's the neat thing, it'll keep running until the battery is drained to a half a volt. And normally people throw batteries away when they get down to 1.1 volt or 1 volt. They're tossed all over the trails in Nepal. You'll find dead batteries that people used in their cameras, and they tossed them out. We pick those up, and we're able to run these for days off of a dead battery. And so you can bring half the number of batteries on your trip, use them for your camera, and then, when they're dead, use them for your flashlight. And that's thanks to the Joule Thief circuit. It's an incredible circuit. So dead batteries, zinc, aluminum foil, doesn't matter. You can light and have light for the rest of your life. So let's build one now. The components are very, very simple. They're right here. You need a transistor, and this is a, excuse me if I'm getting it wrong, 2N9304. I think it's the number on it. That we'll put up on a link with this video. I think it's 23N904 is the number, but we'll show you which transistors you can use. But it's a single transistor, a ferrite torus or core or donut, whatever you want to call it. It's ferrite, meaning that it's not magnetic itself, but it will respond to a magnet. So you'll know it's the right thing if magnets adhere to it. It needs to be made of iron, although it itself is not magnetic. And then you need a 1 kilo ohm resistor, and of course your 3 volt LED that you're going to light, and then some double-stranded and hopefully double-colored wire that helps you out. So the way that you do it is your first step is to cut a piece of wire the length of your arm, roughly. Right, and then of course strip the ends. Okay, excellent. Now run it through the bead, as they call it, or through the center until it's halfway through. And then take one of the sides, once it's about, try to put it in the equidistant, and then start wrapping so that you get ultimately 11 to 13 coils. Okay. You don't need more, and it shouldn't be less than 10. And this is to create what's known as an inductor, which creates a magnetic field which grows and then collapses and acts in a sense as an electron pump, because as the field collapses, it sends electrons through, and then as electrons arrive to create the field, the field grows. And so the inductor, I like to think of it, I'm probably not describing the physics adequately, but I like to think of it as a kind of pump that stores energy in the field as it grows. And that's why it's able to harvest half a volt. And that's what the aluminum reaction or the zinc reaction with air gives between a half a volt to about 1.2 volts. Average is about 0.7. And that's why the Joule Thief can use it to light a 3 volt LED with the transistor. Yeah, and sort of bunch them as, as close as you can. But as you can see from the finished one, it doesn't have to be very meticulously done. You can afford to be a little bit sloppy with it.
Halfway through.
Halfway through?
Okay. Was this side?
Then do the other side. Do you know how many wraps you've done? You've done 12? Okay, if you have room for a 13th, go ahead and do it. If not, don't sweat. You do, okay.
Okay.
Okay, so you've got about 13 coils, is that right?
Yes.
Okay, and you've got a red and a white wire sticking out of both sides. Take one of the red wires from one side and one of the white wires from the other and twist them together.
First of two. Okay, white and red.
White and red, exactly. And that forms the positive lead that goes to the positive terminal of the battery. So even just to keep it in mind, you can go ahead and grab this. I can't even get this apart, but take one of these batteries off and yeah.
Okay.
These neodymium magnets are really and the only reason for the neodymium magnets is to make it easy to connect to the
batteries.
To the battery. So you can go ahead and just touch that on.
Okay. To which one? To this one? No.
Yeah, the positive. So does it even stick to it? Sometimes that wire doesn't really stick, does it? That's not going to go on, of course, because there isn't any.
We have nothing to show.
Right, just knowing that this is the positive.
Okay.
Okay, so that's the ferrite core, and that's the main engine of the Joule Thief, along with the transistor. So we're going to take the red wire.
Where do we go?
From the other side of the core.
Okay.
Yeah. Take the red wire from the other side of the core, and that red wire is going to go to the LED, and it's going to go to the positive lead of the LED.
Okay, we got that.
Okay. Now you're going to come from the negative lead of the LED.
Yeah.
With a wire that goes to the negative terminal of the battery.
Okay.
It's not sticking, is it?
No, it's not sticking.
There's a way we can. Well, you know what? Use one of these.
Ah, yeah. Great.
Because that'll stick. And let me give you one.
Okay, we got it.
And for the positive, we'll give you that one.
Okay.
So go ahead and hook that. That goes to the positive.
This one here?
Yep. That goes to the positive terminal of the battery.
Okay.
All right. So as you see, nothing's happening. The circuit is complete in a sense, but the Joule Thief isn't pumping electrons yet because we haven't hooked up the transistor. So now comes the transistor. But before the transistor, we have to have a resistor. So coming off of the white wire, go into the breadboard and then into the 1 kilo ohm resistor.
Okay.
Right as rain. And now, coming out of the resistor, you want to take the resistor output, and that should go to the, what I like to think of as the faucet of the transistor, that is the base of the transistor, which is the middle, the middle pin. So that's going to be your faucet that turns the electrons up and down. And notice that it's coming from that inductive coil, so that as the electromagnetic field grows and then collapses, it's pushing electrons, as I like to think it, through the resistor and then to the base of the transistor, and then that's opening up current.
Yes.
In a pulsed way.
Okay.
Okay, and that's going to happen at very high frequency. Then in the transistor, you have the emitter and the base. And looking at the flat side, which is the side we're looking at here, excuse my bad camera work, so it goes emitter, base, collector on this particular transistor. The emitter needs to be connected to the positive lead of the LED. Exactly. And then the collector needs to be connected to the negative lead of the LED.
Whoa.
And boom,
Here we go.
it lights up. It's really that simple. And maybe,
Great stuff.
yeah, Dominic, could you explain that in German while I got the picture of this board?
Hier mit meinem Kollegen Dr. Thomas Kahn. Und wir haben in der Erklärung einen Joule Thief, also einen Juwelendieb, auf plain Deutsch übersetzt. Was wir hier haben, ist eine einfache Stromverbindung an einer 1,5 Volt Batterie, mit der wir aber eine LED leuchten, die eigentlich 3 Volt benötigt. Und die Magic, das Wunder passiert in diesem kleinen Teil, das wir den Joule Thief nennen. Und es ist eine Art Induktor. Es ist quasi magnetisch und er sorgt dafür, dass aus der Batterie zusätzliche Elektronen gezogen werden. Um das zu realisieren, wird ein zweiter Stromkreis gebaut, den man hier schön mit dem weißen Kabel sieht. Wir gehen auf einen, what's the name again?
I think it's a 23904 transistor.
It's a transistor. Ja. Und wir haben hier eine Verbindung zurück auf die Base, mit der wir quasi sagen, dass der Transistor sich öffnet und haben dann eine Verbindung wieder auf die Batterie. Und sorgen quasi zusätzlich dafür, dass die Batterie abgibt.
So, the Strom in Realität, the electricity comes from the negative terminal, goes through to the negative terminal of the LED, and then the negative terminal of the LED is also connected to the collector, which makes sense. The electrons are being collected by the transistor. The transistor emitter is then going over to the positive terminal of the LED. The positive terminal of the LED is also connected through the ferrite core or torus and then traveling to the positive terminal of the battery. Gleichzeitig, at the same time, the base of the transistor is connected through a 1 kiloohm resistor through the inductor and then of course back to the battery. That takes advantage, as Dominic was explaining in German, of the fact that there's the other way that electronic circuits have thought of, where the negative, where the positrons, so to speak, the protons, would be controlling the faucet, so to speak, or the base of the transistor, allowing in pulses the electrons to be sucked through as the magnetic field here grows and collapses and grows and collapses. And allegedly that is how this is able to take a dead battery that is down to a half a volt, from 1.1 or 1.2 volts down to a half a volt, and continue to raise up the current and the voltage to light a 3 volt LED. And that is also what enables us to dispense with the battery altogether and instead hook our negative terminal to a piece of zinc piping, and our positive can go to a piece of stainless steel, or if you have a spoon anywhere or any other thing, let's even try
Yeah, the bottle opener.
the bottle opener and see how that works. So we can hook the positive to any kitchen utensil and then take a piece of paper towel that has been soaked in drain cleaner, and we see it blinking. It's just taking a few seconds with the zinc. The zinc oxidizes so fast that it takes a few seconds to get it to work. Aluminum tabs can sometimes work better with the negative terminal, and as you see, the aluminum tab works quite nicely. But my discovery was that the more surface area that you have of stainless steel, the better reaction you get. So when I use this scouring pad for the kitchen, which has a lot of surface area, then I'm able to get a super bright LED. So yes, you can use a spoon. And let's even see what happens if I hook up to this and I put it and touch it with this. As you can see, it gets even brighter. The more of the positive surface area you have, the brighter you're going to get and the more LEDs. So now I think what we should try to do is stick more LEDs in and see how many we can get lit off of a single tab of a beer can. And I'll just put this on for weight. Oh no, that caused a short circuit. Don't want to do that. Let me put this on top of it to hold it down. Because as you can see, if it touches, it gets brighter. So let's see how many LEDs we can put in parallel here. Please note that this side of the breadboard is not relevant to this. If you were getting confused and you're thinking, wow, it looks complex, that's from another experiment. So we're really dealing with just a tiny portion of the breadboard. Yeah, you can see it glowing, but very dimly. Use the one that is identical.
Yeah. It's red.
Yep, there you go. And this is a different color. This is the warm glow, and that's the white. For some reason, the red and the whites take a lot more energy, and I don't know why. And yet you can't read by those. These you can read by. And as you can see, it's not diminishing in brightness appreciably. So let's see if we can add another.
So just it's a red one. So we'll see.
That's weird with the reds. See, it goes out and just the red one goes on, and I don't know why that is.
I have a yellow one.
Let's see what the different colors do. It would be interesting if only the whites work with it. And of course, we can then try only the reds. Yeah, the yellow takes it out. No other.
Let's try green.
Green. Probably going to be the same because it's probably the same type of stuff.
No, it's the same as the green.
It's the same. Let's see what we should try. Let's take out our white ones and just try the colored ones. And remember, folks, this is coming right off of a single aluminum can tab. That's all we're doing is just placing this with a wet paper towel. The paper towel is wetted with sodium hydroxide or potassium hydroxide. So there's one LED. There's two, and both on. There's three. They're getting a little bit dimmer. Not so much, though.
This one is not working.
If anybody can write in and say why it is that you need LEDs of the same basic type to work and why otherwise they contradict each other. The warm glow white and the bluish white all work fine together, and you can just add as many as you like. And the colored RGB ones are red, sorry, not RGB, but red, yellow, green LEDs certainly also work. And as I say, coming off of a single Coke can tab, and we were using a spoon, or actually a bottle opener, but the more stainless steel we have, the brighter we're able to get the reaction to go. So we're at 4.
No. Oh wait, it was 2.
Okay, 5.
I'm running out of LEDs.
I have some here too as well. 6. Oh my gosh.
Quite powerful.
Yeah, off of a single tab of a can. 7.
Okay, so now the breadboard space is gone.
Oh, okay, because I have one more LED, no space for it, huh?
Probably.
So it's kind of like an inexhaustible, wow.
Yeah. But they're now getting...
They're getting a little bit dimmer.
Yeah,
Still useful for projects.
definitely.
Yeah, and then what we could do is, of course, we could use more Joule Thieves and more tabs. I wonder what happens if can you hold this a second? If I add more aluminum, I have found no evidence that more aluminum makes any good difference. So I can put 3 tabs on, or does it? That's kind of the same. So it isn't really the amount of aluminum. Until all the aluminum is dissolved, it isn't going to matter. It's still going to pump the same amount. Even a tiny piece of this aluminum foil will give you the same reaction. See? And that's really tiny. I mean, how tiny can I get? And then go, teeny tiny, okay, there's a little teeny piece of aluminum. And I get the same basic reaction. So it isn't really so much this source. It's more a question of how much of the stainless steel you have, so that if I just take a tiny piece of the stainless steel and put that underneath and then use this, well, no, they're still going on. They're still going on. It just seems, no, but see how much brighter it is. Look at the difference. Okay, so there's with a single piece and there's with a larger piece. You get appreciable brightness. So for some reason, the more of the, and what would we call this? It's attached to the positive terminal, so it would be the cathode of the battery, if you like. So the more of the cathode we get, the better the reaction. But it is quite remarkable that one can use all of this stuff. And what we have to figure out now is a way to make it easy for people to simply pop the tabs in.
Yep.
There are kits like this Echo Power kit that take magnesium plates, and they've built a way for you to take the magnesium plates and pop them into a plastic housing and then run this car off of the electricity produced. But not many people can find magnesium in their daily life, whereas Coke can tabs and bits of plumbing are found everywhere, as are these. There's also kits like the Limo-Uhr, the lemonade clock you probably all know, that comes with little plates of zinc and copper to light a small watch. And we would replace those with these easy-to-find scrap aluminum pieces, but they have the little behalter, the little housing for it. So if we can design something that makes it really easy for people in developing countries to simply drop one of these in and put a few drops of wood ash from their campfire, and then bingo, they've got light for the village, and they can read, and they can navigate and not get bitten by scorpions or snakes, as happens when you're on these trips in places with no electricity, and avoid using kerosene lamps with the toxic effects. Then we have a real development solution that is sustainable, given that everywhere in the world there's either a bit of zinc roofing or there's cans. Thanks.
Hello, today I'd like to show you how to make a biogas system from this tank. It's really simple. All you do is put 3 pipes into the lid of the tank, and basically you're done.